this is Notes 2.2, Atoms, Isotopes, and Ions. And in your textbook, this is going to be pages 106 to 125 and pages 45 through 58 in your study guide. So let's talk about the subatomic particles, the particles that make up an atom. And this is going to be a review for many of you. You should have learned this in the 8th grade. And we talked about it some last week. So the subatomic particles of an atom are the protons, neutrons, and electrons. And here is an illustration of an atom here. And so in the very, very center, really small, are the protons and the neutrons. Okay, and those are in the nucleus. And then around the outside of the nucleus is the electron cloud, where the electrons are found for that atom, the electron cloud outside of the nucleus. So for your protons, the symbol for a proton is a P with a plus sign because the charge of protons is positive. Neutrons, it's going to be a lowercase n with a 0 because the charge of neutrons is neutral or 0. And then for the electrons, it's a lowercase e with a little negative sign because they are negative. So when we talk about the mass of protons, neutrons, and electrons, we talk about them as being an atomic mass unit, 1 AMU. So a proton has 1 AMU, a neutron has 1 AMU, but the mass of an electron is only 1/1800th of an AMU. So it takes 1,800 or 1,800 electrons to equal the same mass as a proton or a neutron. So even though it does have mass, it's very small. So many times it's not even counted as part of the mass of the atom. So you'll hear sometimes that electrons have no mass, but that's technically incorrect because it's 1/1800th of one proton or neutron, 1 AMU. Okay, so when we talk about symbols, chemical symbols for elements, on the periodic table, you're going to look and you're going to see that these chemical symbols are written in all capital letters. If it's just one letter that represents that element, it's going to be a capital letter. But if it's two letters that represent that element, the first one is capital, and then the second one is going to be lowercase. Now, I've changed your canvas up just a little bit. And if you'll, next time you look in your canvas, you're going to see the home page has changed. It now looks like this. And I have some links here that you can click on. This is the electronic textbook. This is how to write up your labs. These are the reference materials that I gave you to glue into the front of your your notes book. And then I also have a link for a periodic table. So when you click on that link, it brings up this website where you can look at the different individual groups that we talked about, transition metals, noble gases, things like that, or you can look at individual elements. If you'll notice here in this section right here, it gives you all the ones that are solid. If you put your cursor over that, the liquid ones, the gas ones, or if you touch just one of the elements, then it'll give you information here about the element. So the atomic number up at the top, we know the periodic table is arranged according to the atomic number, which is the number of protons. Then you have your symbol, then the name of the element, and then the average atomic mass, which we're going to talk about in just a moment. Up in the upper right-hand corner, you can see the electron configuration. So we know for beryllium, it has 4 electrons. So if you add those two numbers up, you get 4. We know that it's got 2 orbitals because it's in period number 2. So it's got 2 electron shells. The first shell can only hold 2. Remember, we talked about that. So if it only has 4 and 2 are in the first shell, then the second shell can only hold 2. But the second shell is capable of holding 8. So if we look here at neon, we see that it's 2, 8. Okay. And then when we go to sodium, we have a whole new electron shell. So it's 2, 8. And then that third orbital is going to hold 1. And then for magnesium, it's going to hold 2, and et cetera, as you go across the periodic table. It adds 1 until it gets up to 8. Then we start a new period. Okay. So here is a picture of that periodic table, the chemical symbol. Remember, capital letter, then lowercase. That has to be written that way. All right, so let's talk about isotopes and ions. I'm sorry, isotopes and isotopic notation. We talked about ions like last week, I think, and remember the definition of an ion is an element where the number of electrons has changed. That makes an ion. Well, now we're going to talk about isotopes. So write down this definition of isotope. All right, an isotope is an element from the periodic table where the protons, or the atomic number, that's the same thing, atomic number tells you protons, stay the same, but the number of neutrons is gained or lost. So now we're talking about changing neutrons. So the isotopic notation is like this. And the way I remember these numbers and how it's written is I remember Big Mac. So, you know, McDonald's sells Big Macs. So the big part represents the symbol of the element written big. And then the Mac represents in the upper left-hand corner is going to be M, mass number. That's the mass number. So the mass number for this carbon, this isotope of carbon, is 14. Okay. The mass number of this one is 13. The mass number of this one is 12. And the mass number of this one is 11. So the mass number is in the upper left-hand corner. A, so the A in Mac, A here in the lower left-hand corner is the atomic number. So you can see on each one of these carbons, atomic number stays the same because it's the number of protons. That doesn't change. And then in the upper right-hand corner, the C, that's the charge. So if this has an ionic charge, then it's going to be in the upper right-hand corner. Now you see on these examples, there's no number in the upper right-hand corner. So we assume that then the charge is 0. It's a neutral atom of each one of these. So on each one of these, the only thing that's changing on all of these is the mass number. Okay, so the ions, there's no ion. The ionic charge is staying the same, so the electrons are staying the same. Of course, the protons stay the same, all of the 6s, because the protons don't change. So the only thing changing here is the mass number. So if the electrons don't change, if the protons don't change, the only thing that can change is the neutrons. So each one of these is a different isotope of carbon. We have carbon 11, carbon 12, carbon 13, and carbon 14. Now you may have heard of carbon dating, and what they do is they look at the isotopes that are in that sample to find out, you know, how old something is. All right. So let's check for understanding here. So if you change the number of protons, what do you get? A new element. All right, so if we change the number of protons, you're going to get a totally new element. How are elements arranged on the periodic table? By the atomic number. Okay, so it's the number of protons. If you change the number of neutrons in an atom, what do you get? Changing the number of neutrons in an atom. That's going to give you an isotope. And if you change the number of electrons that are in an atom, what are you going to get? All right, that's going to be an ion. So make sure you know these vocabulary words because we're going to use these words a lot and you need to know what they mean. All right, so a lot of times you're going to see an isotopic notation written like this, and then it's going to ask you questions. So how many protons does this element have? Well, first of all, what is the element? Cl. Now that's an L, not a 1, because this is Times New Roman font. The L's look like 1s. So Cl. So let's go back to the periodic table. Cl is right here. So this is the chlorine atom. So for this chlorine atom, how many protons does it have? All right, so remember, protons are the atomic number. when we're looking at the isotopic notation, MAC, mass number, atomic number, and charge. So the atomic number is the number of protons. So this is 17 here for the number of protons. So how many neutrons does this have? Well, if this is the mass, 35 is the mass, and you have 17 of that 35 are the protons, how do you get the neutrons? Well, you just have to subtract. So if we take 35 minus the 17 protons, whatever is left over has to be the neutrons. So for this example, it's going to be 18. So you can take 18 plus 17 and you should get 35. So we're adding the protons and the neutrons together, gives you the mass of that atom, 35. So how many electrons does it have? Well, in a neutral atom, it's going to have the same number of protons, 17, but this is not a neutral atom. This is a -1. So if you just see a negative sign there, that means it's understood to be 1. We don't write the ones. So this has gained an electron. So it doesn't have 17, it gained 1. So now the number of electrons is 18. So that's how you read an isotopic notation. Now, sometimes also you're going to be given information like this, like it has a mass number, you have the atomic number, and you have the charge. Okay, and it asks you how many protons, neutrons, and electrons, but then it asks you to write the isotopic notation. All right, so how many protons does this have? Well, protons is equal to the atomic number, so the atomic number is 26, so this has 26 protons. How many neutrons does it have? Well, if it's a mass of 60 and 26 of that 60 are the protons, then we subtract 26 from 60, and that's going to tell us the number of neutrons. So that's 34. If you take the neutrons and protons and add it together, 26 and 34, you should get your 60 back. How many electrons does this have? Well, in a neutral atom, it's got the same number of electrons as it does protons, so that would be 26, but this has a charge of a +2. When you have a positive charge, it has lost electrons, because remember the protons are positive, so if you lose electrons, if you lose those negative charges, you're going to have an overall positive charge. So if we lost 2 electrons, 2 from 26 is 24. So it has 24 electrons. All right, so write the isotopic notation. Well, what element is this? We always look at the protons to find the element. So the element is element number 26. So if you go back and you look at your periodic table and find number 26, right here, that's going to be iron. So iron is the element. So we're going to write the symbol big. All right, MAC, M, right here in the upper left-hand corner is going to be M, mass number. So we're going to take this 60 and we're going to put it here. A, atomic number. So it's the number of protons. So I'm going to take 26 and I'm going to put it here. And then C, charge. So the charge is a +2. So I'm going to take this charge and I'm going to put it right there. So this is the isotopic notation for this isotope and ion of iron, this particular species of iron. That's how you write that. All right, the last thing that we're going to talk about is the average atomic mass. How is the average atomic mass calculated? Well, if you look at carbon as our example, on the periodic table, it's atomic number 6. Here's the symbol, and then it has a mass or an average atomic mass at 12.011. Well, you might be thinking to yourself, if carbon has, each proton of carbon has 1 AMU, and each neutron has 1 AMU. Those are whole numbers, so why is the mass down here a decimal? Because if I add whole numbers, I should get a whole number, right? Well, that's because this is not the mass, it's the average atomic mass. So write down the definition of average atomic mass and I'll show you how that's calculated. All right, the average atomic mass is the weighted average mass of all naturally occurring isotopes by abundance. So here's the formula. You take sigma, that's a Greek letter sigma. It means to add up or to sum whatever's in the brackets here. So we're going to take the percent abundance. So you have to know the percent abundance times the isotopic mass of that particular isotope of carbon. So here we see carbon 12 and carbon 13. So these are whole numbers. So this has 6 protons, 6 neutrons, which gives you the number 12. But that's not the only species of carbon that's in the world. So here, for this example, it tells us that we have carbon 12, but there's also a carbon 13 that exists. So carbon 13 has 6 protons, but it has 7 neutrons to make 13. So for carbon 12 and carbon 13, here is how abundant it is on Earth. So of all of the carbon that's on Earth, 98.89% of that is carbon 12. So it's this species of carbon. And then 1.11% of it is carbon 13. So to get your average atomic mass, it's kind of like getting your average in a class where you have 60% of your grade is made up by tests, 30% is made up by labs, and 10% is made up by your daily grade. That's called an average. That's how you get the weighted average of your grade, is using the percentages. So let's take this percent and multiply it by this isotopic mass, and it should give us a number out here, but we can't multiply by a percent, so we have to change this to a decimal. So you know, to change a percent to a decimal, you move the decimal place 2 times to the left. So it's going to be 0.9889 times 12, and on your calculator, you should get 11.8668. So go ahead and try that, because you're going to need to be doing this for practice on a practice sheet. Okay, carbon 13 is 1.11% abundant. So if we take and make that a decimal, 0.0111 times 13, you should get 0.1443. All right, so for this example, we're only working with 2 isotopes of carbon. So we're going to sum up these answers that we got, the summation of these. So we're going to take 11.8668 plus 0.1443. We're going to get 12.0111. All right, so if we compare that now to the average atomic mass on the periodic table, we'll see that these numbers are the same now. So this number is not the atomic mass. It's not the mass. It is the average atomic mass of all of the isotopes of carbon that exist, that we know about. Okay, so that's why that number is a decimal. We're going to be doing some more practice on this. So finally, before we leave, scientists that you must know, write down these 6 scientists and what they did, and we're going to talk about these in class and their contribution to the atomic theory. All right, so thank you for watching this. Make sure you come to class with your notes. And if you want to make sure that you know when I put up new videos, then hit that subscribe button in the lower right, slap it in the face, and also click the bell and you'll be notified of when I put up new videos. All right, thanks, and we'll see you in class.